In this video, I'm going to do some very basic, simple examples of number manipulations of different types. Okay, now this is a number line. You got 0 here and you got 1 here. So, and this is divided into 4 equal parts. So the question is, which arrow is plotting to 4/7 on the number line? Now, whenever you have a question like this, it's always good to write what each. So this is 0. This is 1. So one whole has been divided into 4 equal parts. So this is 1/2. You can say this is exactly in the middle. And this is half of half, which is quarter. So 1/2 is nothing but 2 quarters. And this is 3 quarters. And this is 4 quarters. Okay, 4 quarters is 1. Okay, so here this is 1 quarter. So A is, we cross out A is not the answer, B is not, D is not the answer. E, I don't know about, so there are 3 options here. This is B, C, and E. Now, I would like to look whether B or C. Let us look at B and C. Now, 1/2 can be written as 2 quarters, or that is same as 4/8. Okay, so this is very interesting. You got, this is 4/8. This is nothing but 4/8. So now my question is this 4/7 or this 4/7? So I'll put 4/7 and a question mark here. I don't know whether this is 4/7 or whether this is 4/7. So yeah, from the diagram I can see, oops, I need a smaller eraser. So this is only a question mark, so I don't know. Okay, so let us think about it. So this is to the right and this is to the left. So my question now should be, if this is 4/7, is 4/7, so I'm asking a question now. So always, whenever you want to learn anything, you have to have heaps of questions. So my question is 4/7 greater than 4/8? Or the same thing is 4/7. So the same thing can be, if you put like this, is 4/7 less than 4/8? Okay, now before I answer that question, so here in these two fractions, the numerator, the top numbers are equal, the bottom numbers are different. So to explain that, or to understand that, so let us write, whenever, suppose you have 1/2 and 1 quarter. 1/2 and 1 quarter, which is greater? Obviously 1/2 is greater. Okay, 1/2 is greater. Okay, now if you take 1/2 and 1/3, which is greater? Again, 1/3 is greater. So if the numerator, the top numbers are equal, smaller the bottom number, greater the fraction. Okay, so let me take one more example. Suppose you have got 1 quarter, 1 quarter and 1/5. So if you're good in fractions and decimals and percentages, this quarter is 25%. So let me write this. I hope you understand it's 25%, or 25 out of 100, and 1/5 is 20%. So 1 quarter is greater than 1/5. Or if you think, if you don't know percentages, just imagine 1. Suppose, let me draw this. Let me draw a circle. You should understand. Suppose this is a circle. This is a circle. And I'm going to highlight, so explain that. So I'm going to copy this and paste it here. Okay, oops. So this is, I'm going to divide this into quarters. So let me divide this into, most of you can understand what I'm trying to explain. So this is a quarter, and this I'm going to divide into fifths. So if I divide into fifths, this is fifth. So this is a quarter, and this is a fifth. Okay, so which is greater? This is a quarter, and this is a fifth. Okay, so here, so let me write here. This is a quarter. This is 1 quarter, and this is 1/5. So you can see 1/4 is greater than 1/5. Okay, so now using that same logic here, let us answer this question. Which is greater? The top numbers are the same. So 4/7 is greater. So this is right. 4/7 is greater than 4/8. This is not right. Okay, as the bottom number is smaller, the fraction becomes bigger. So the answer should be, which arrow is pointing to 4/7? Obviously, this is not the answer. So this is 4/7 is nothing but C. So here our answer should be C. So 4/7 is, because this is less than 4/7. This is 4/8. So 4/7 is greater than 4/8. So this has to be to the right. So this is the answer, because this is the error. Okay, the next question. This is one box. This is not drawn to scale. So this box has, the length is 3 centimeters, the width is 4 centimeters, and the height is 2 centimeters. Here, this is a box. It's partially drawn. This is 4 centimeters, 2 centimeters, and we want to find the height of this box. So what information do we have? How high is box D if it has 3 times the volume of box C? So the volume, when you want to find volume of box C, so let us write the volume of box C. So this is what is given. Volume of box C, sorry, box D. Volume of box D if it has 3 times the volume of box C. So volume of box D has the volume 3 times volume of box C. This is what is given. Okay, so whenever you have a statement, try to write an equation out of this. Now volume of a box is length times width times height. So can I say this is 3, this is the length, so 3 centimeters times 4 centimeters times 2 centimeters times 2 centimeters is equal to 3 times the volume of box C. The volume of box C is 4 centimeters times 2 centimeters times question mark centimeter. Okay, so this is how much? So this is 4 times 3 is 12. 12 times 2 is 24 centimeter cube. Okay, is equal to, this is 3 times 4 is 12. 12 times 2 is 24. Am I right? Yeah, 24 centimeter squared times some centimeter. So use your logic. What should be? 3 times 4 is 12. 12 times 2 is 24. Yeah, 3 times 4 is 12 times 2 is 24. So what should come here? So this should also be 24 centimeter cube. That should also be 24 centimeter cube. Now you may wonder, how did you get a cube? Centimeter, when you're multiplying units, you also multiply the unit. Centimeter times centimeter times centimeter is centimeter cube, and centimeter times centimeter is centimeter squared, times this is a centimeter. So obviously 24 centimeters times 1 centimeter would only give you 24 centimeter cube. So the answer here should be 1 centimeters. Okay, looking at the next question, 0.6 is same as 0.6 is same as 6 over 10. This is 6 out of 10. So this is pretty easy. Okay, speed of sound is about 340 meters per second. 340 meters per second. One night, a mopoke calls from a tree 1.7 kilometers away. How long before the sound of the can be heard. I don't know. Or how long before the sound of the call can be heard is the question. Can be heard. That means once the mopoke calls, how long does it take for that to be heard? So this is a question of ratio. So let me make two columns. Whenever you have a question like this, it's always good to make two columns or 2 or 3 columns, whatever is necessary. So your distance and time. So we are relating distance and time. So what is this information telling me? So for 340 meters, you need 1 second. That's the information that we have. And for 1.7 kilometers, so 1 kilometer, hopefully you should know, is 1,000 meters. So 1.7 kilometers, 1.7 kilometers would be 1,700 meters. So 1,700 meters would take how many seconds? That's the question. Okay, so here again, this is a question of ratio. So I should be thinking like this. 174 times what gives me 1,700. So I don't know, that will be too difficult. So I'll go like this. Always good to think. So I know 340 times 10 gives me 3,400 meters. So what happens if I do 340 times 5? Okay, so if you halve this, you have to halve this. So 340 times 5 would be half of 1,400. Sorry, 3,400 is 1,700. So 340 times 5 gives you 1,700. So this has to increase by the same ratio, or by the same proportion. So it's times 5. So it takes 5 seconds before we can hear the call of the mopoke. Okay, and final question here. Okay, this is the 6th question, sorry. So there's one more question. So this is question number 6. Okay, so let me take this slightly up. This is question number 5. 24 of the students who tried out for the rugby was selected. This was 75% of the total number who tried out. How many tried out altogether? So what they are telling us is 24 student is nothing but 75%. Okay, now 75%, I hope you understand, is 3/4. So we can make a column like this. So 3/4 of the students represent 24 students. So basically they're asking you what is 100%. So if 3/4 is 24, 1/4 would be how much? So this is, so if you go from year to year, the same principle. This is 3/4 times 3 should be 24. So this number times 3 should give you 24. So what times 3 is 24? 8. Okay, 8 times 3 is 24. So the same proportion. So if you add this, you can add this. So 3/4 plus 1/4 is a whole. Whole would represent 32 students. So the whole altogether there were 32 students. 32 is the answer. Okay, now the final question. Now this is a set of hexagons. They all are together. So this is all also called tessellation. So this is I have moved this, or if I bring this, so these are all equal or congruent hexagons. So what's the measure of this angle? So this is angle at a point. Suppose you know angles at a point gives you how many? So if this is x, I can say this is also x, and this is also x. So can I say 3x plus x plus x? I can say x plus x plus x is 360. Angles at a point adds to 360, or 1 full turn. This is 1 full turn. So 3 times x is 360. So I want to get rid of this 3, so I'm going to divide both sides by 3. So 3 times x divided by 3 is 360 divided by 3. So x is 120 degree. X is equal to 120 degree. Hopefully these examples are helpful.